In this lesson, we're going to learn how to combine like terms in an expression. Let's go ahead and look at this example here first to kind of help us dive into this concept. So let's consider the following takeout order that a family makes at the local McDonald's. So you pull up to the window and you ask the person at the window for 2 burgers, a fry, a drink, 3 burgers, 2 fries, and 2 drinks. And then they look at you funny. And the reason they look at you funny is because you did not consolidate your order. You didn't shrink it down into its simplest terms. So in this example, let's go ahead and represent burgers with a B. We'll use the variable B because it seems like a reasonable variable to use. Fries, let's go ahead and use an F. And then a drink, let's go ahead and use a D. So I'm going to go ahead and represent what I have here using variables. So let's go ahead and begin with these 2 burgers. I'm going to use 2B for burgers to represent those 2 burgers. I'm going to represent this fry here by saying plus 1 fry. Here's my drink. I'm going to say plus 1D. 3 burgers, so plus 3 burgers. 2 fries, so plus 2 fries, and then my last 2 drinks, so plus 2 drinks. Now what I want to do is I want to take all the variables that are the same and I want to smush them together. So let's go ahead and start with the B's. I'm going to go ahead and change my pen color here so I can show you. Notice that I have 2 B's and then I have 3 B's. So I can add those 2 together to give me 5B. So I'm going to say 5 burgers total. Now let's go ahead and work with the fries. I have 1 fry and then I have 2 fries. And if I add those 2 together, that's going to give me 3 fries. And then the last one, I'm going to go ahead and say, I might need a little darker pen here. Here we go. 1 drink. And then 2 drinks. So 1 plus 2 is going to give me 3 drinks. So what I did there is I consolidated my order. So now when I pull up to the window, I can say I would like 5 burgers, 3 fries, and 3 drinks. That is the underlying concept behind combining like terms. So now let's go ahead and look at some examples that have numbers in them. So what I want to do here first is I want to take a look at like terms, and what I want to do is figure out what are like terms. Well, like terms are terms that have the same letter attached. So the number in front doesn't necessarily make a difference. It's really the variable that's attached to it. For example, it says circle the terms that are like 4x. So when you look at the terms below, you need terms, you're looking for terms that have the x. I sometimes like to say they have the same last name. So you can see here that my first example is negative 3y. Well, y is not the same as x, so that is not going to be one of our answer choices. 8xy, well, xy is, yes, there is an x there, but there isn't a y, so they're not the same, so he's not a like term. Negative 7x, well, you can see that I have an x in both of those terms, meaning those 2 are like terms. Even though this term has a 7, actually it's a negative 7, it doesn't really matter. The number or the coefficient in front of the variable has nothing to do with it. It's all about the variable. The next term is 4x squared. Now, x squared is similar to x, but it's not quite the same. It needs to be identical, so it's not a like term. 10x is definitely going to be one of our like terms because x is the same. And then 4. Well, 4, we learned last unit, is a constant. So 4, just because it has the same number, doesn't mean that it's a like term, because again, the variable has to match. In the next example, it says circle the terms that are like negative 3y. So I'm looking for all of the terms that have a y. So the first example is 7y, which is a like term. The second example is negative 3y squared. Well, y squared is not the same as y, so that's not going to be a like term. Negative 8y. Well, that has a y, and it's only a y, so I'm going to go ahead and circle that as a like term. Negative 9yx, not a like term because yx has an additional x in there. We don't need that x. 3xy, well, it looks similar, but it's not the same. And then y, this is a tricky one. So just because it's all by itself doesn't mean that it truly is by itself. Remember that when you have a variable by itself, it has a 1 in the front. So either way, it is a like term because it matches our term that has a y in it. In the third example, I have negative 6y squared. So I'm looking for the term that has a y squared in it. So look for all the terms that are y squared. My first term is not going to work, but my second one is. My third one is x squared. It's not the same letter. The fourth one is just negative 6. There's no variable. All right, negative 3xy squared is a little tricky because it does have a y square in it, but you can see that it also has an x in there, which is not going to make it a like term. It has to be identical. And then the last one, negative y squared. Well, the negative, remember, you can just put a negative 1 in front of there. So this is going to be a like term because of the variable y squared. All right, the last one, 9xy. I'm looking for terms that have the same last name. So 4y squared, that's not going to work. 10 is not going to work. 2xy, well, that's the same last name. Or I'm really just looking for the xy. If you have the xy, it's a like term. 5y squared is not a like term. Negative 3xy, that's a like term. And negative 2y is not a like term. All right, so what we did there is just figure out what are like terms. Now, let's go ahead and put it all together. All right. In these examples, I'm going to go ahead and I'm going to use multiple colors to represent my like terms. You don't have to use multiple colors. It's just sometimes a little bit helpful to separate these terms. So let's go ahead and circle all of the like terms. Now, as I circle my like terms, you're going to notice something. I'm going to not only circle the term, but I'm going to circle the operation in front of the term. So the operation in our cases will be addition or subtraction. So I'm going to go ahead and circle them. So my first term here is 3x. So I'm going to go ahead and circle him. And I'm going to go ahead and look and scan across my expression and find that I also have positive 5x. Now the reason that I circle that operation in the front is because this is the operation that's going to tell me what to do. This is going to say 3x plus 5x. That is going to consolidate down to 8x. So if you forget to circle the operation in the front, it's easy to forget what operation that you're doing. All right, I'm going to go ahead and I'm going to grab a different color now, and I'm going to work with my y's. So I have positive 2y plus 6y. So positive 2 plus 6 is going to give me 8, and that's going to be a positive 8. So I'm going to go ahead and write it like this, plus 8y. And what you did there is you consolidated it into one answer, and this is my final answer. I'm going to go ahead and put a box around it. All right, my next example. Let's go ahead and pick a variable that you'd like to begin with. I'm going to go ahead and begin with y. I usually like to start with whatever comes first in line. So 8y, and now I'm going to go look for my other y's. So you can see over here that I have a negative 3y. So I'm going to circle negative 3y, and it's very important to circle the negative because that's going to tell you the operation. 8y minus 3y. That's going to give us 5y. I'm going to go ahead and grab a different pen color, and I'm left with positive 4x minus 6x. Positive 4 minus 6. Be very careful with your operations. That's going to leave us with negative 2, which is, I'm going to write minus 2x. And I'm going to put a box around my answer. All right, my next problem. Feel free to pause the video at this point too and try a couple on your own. All right, here we go. I'm going to go ahead and start with the first term, negative 8g. And I also have a positive 3g. So I have negative 8g plus 3g. That's going to leave me with negative 5g. Be very careful that you don't say positive 5g because it's not positive. All right, negative 5h minus 4h. Think about it. Negative 5 minus 4 is going to leave me with negative 9h. And I have combined all those like terms, so that is my final answer. And then the last one here, let's go ahead and do that one. I'm going to go ahead and circle negative a and then negative 4a. Now be very careful here. Like we talked about earlier, the negative a has a negative 1 in front of it. So it's really negative 1 minus 4 is going to leave us with negative 5a. And then the last part here, I have positive b plus 10b. Well, positive b, remember there's a 1 in front of that variable. So I have 1, positive 1 plus 10 is going to give me plus 11b. And I have combined my like terms. All right, now let's go ahead and bump it up just slightly. Now I'm going to add some more variables, different types of variables, and some variables that just might look a little bit different. So let's go ahead and do the same concept here with this one. So I'm going to go ahead and combine 4xy, and I'm going to scan across my expression and identify anything that is a like term. And I do have a like term. I have a positive 1xy over here. So I'm going to go ahead and combine them. 4xy plus 1xy is going to leave me with 5xy. Then I'm going to go ahead and work with my positive 2x squared minus 3x squared. You can see those x squares are like terms. So I have positive 2 minus 3. That's going to leave me with negative 1x squared. Now, you could rewrite this if you really want to get technical. You could rewrite it with your 5xy minus x squared, because you don't have to represent that 1 in front of the x squared if you don't want to. Either one of these is perfectly fine as your final answer. So I'm going to go ahead and I'm just going to circle both of them. All right, let's try another one. I have 7a, and then I have minus 7a. This is a unique one. 7a minus 7a. Well, 7 minus 7 is 0. So what happens here is they actually just turn to 0, and we don't write 0 because we never write 0. They really just cancel each other out. Then I have some other terms. Let's go ahead and look at the next one. Negative 4a. And I cannot combine that with the positive 9 because they're different terms. A and a constant are not the same. So I'm going to rewrite this guy as negative 4a. And then I actually have a third term here that is unlike the others. So I'm just going to rewrite him as positive 9. And that is as small as I can consolidate this expression. All right, we're getting a little bit more complex. Let's go ahead and work at the next one. I have negative x, and then I have negative 5x. Those are like terms. So really, I have negative, there's a 1 in front of there, right? So negative 1 minus 5. That's going to leave me with negative 6x. Go ahead and change my pen color. Now I have positive 10y. But positive 10y does not combine with negative 3, the constant. So I'm just going to go ahead and carry this term straight down because I cannot combine him with anything else. And then I'm going to finish it off with my last term here, my constant, negative 3. And I'm going to carry him down. And that is consolidated completely. All right, my last example for you here. Let's go ahead and work with my y's. I have a y, and then I have a plus 3y. So really that's saying 1y plus 3y. That's going to give me 4y. Now I'm going to go ahead and I'm going to work with my x's now. So I have a negative x, and actually that's all I have. I just have a negative x, so I'm just going to go ahead and bring him down. And then I'm going to finish off my problem by grabbing just the numbers. I have positive 4 and minus 5. Those are two constants. And constants I can combine. So positive 4 minus 5 is going to leave me with negative 1. So now that I've used up all my terms and I've consolidated, I am finished. All right, and that completes our lesson on combining like terms.